Welcome back to Design Thinking and Innovation, the case study section. We are going to be looking at a very interesting case study of how you can actually ideate. The focus is on coming out with creative ideas. So, the focus is only on that. The topic is GeoLights. So, it is section C9, week 9. So, let us have a look at GeoLights. The case study has gone through all the processes. It started with research, analysis, ideation, prototyping, feedback and implementation. It also used all the techniques of brainstorming, mind mapping, interviews, affinities, spatial mappings. Did secondary research followed by primary research, tools for ideation, prototyping and validation, and then we look at now the case study on GeoLights. That is GeoLights. It is guided by Professor Avinash Shinde and the student is Kiran from IIT Guwahati. So, the project introduction says that it started with looking how sunlight could inspire and produce design for capturing energy. Later, it was discovered that by arranging them in a geometrical pattern in space can lead to create enormous number of forms. I mean, you can generate many combinations of these. In the study phase, a lot of details of geometrical patterns have been perceived and other things were also explored about things like origami, energy organic forms, new experiences, creativity and detailing it. In this project, an approach of modularity was also explored, so that things fit into certain modules. It was quite interesting to learn different elements in two geometric shapes, and more interesting was the way it has been perceived and interpreted. Different explorations have also been tried while exploring these and within constraints, and they were also clarified at the end of it. And there is further scope for this project. This is just an exploratory project, but can also add a new dimension of creating forms for architectural applications, where light and energy are maybe a constraint or as an advantage. It can also be seen that street lamps in the future, Geo can also take modularity into another world of creativity in people. So, once you have the basic form, you can explore it in many dimensions. So, first was they took geometric constraints and said that can we actually fit it into different combinations. As you can see, it started with number 1 is a triangle, then a square, then if you look at it, it's a pentagon, hexagon, and then it has got 7 sides, right. So, if you look at the combinations or the fractal combinations of it, you can make actually trees with different combinations. So, the first tree is made out of triangular modular pieces, the second one is with square pieces put together, then it becomes a pentagon, hexagon and heptagon. Here you can see two variations. The one on the left is made out of hexagons and the one on the right is made out of pentagons. So, depending on what is the basic module, the form becomes different. And then you can put a third dimensions to it. It is not just in 2 dimensions it can grow, it can also grow in the third dimension. So, the variation is so much. And then what is the basic module? Can we actually detail that? So, here you can see it's actually a hexagon and then it's been detailed out so that you can have different combinations of it. And then you can explore. Now, you put it into the form of a dome, Okay, so the basic unit is the same, but the overall form is different. And if you can see on the right side, you can actually create a full dome with that. Okay, and you can apply it. Okay, you can apply it in very interesting things. These are almost like curtains in front of your house, but it actually produces light at night, or you can have it inside the house. Again, they become more like curtains rather than lights which are fit on the ceilings. Okay, and you can create different scenarios, like this is an application where you can put it in the garden and it becomes in a garden lamp. Okay, or you can put it in a like an installation in a park, or it could be lighting the bridge itself, the two sides. If you can see that these are GeoLights, in different variations, put on two sides of the bridge itself. Yeah, so these are scenarios. Okay, of course, the basic geometry can be changed into different sides, number of sides, and the extension of it can also be interesting, right. So, this has 6 arms and that has 5 arms. So, it is a dynamic geometry that you can create out of that. Okay. And then you can make third 3D extensions of it. So, this is just the pentagon being explored in different combinations. Okay, and it can form beautiful combinations. Okay, at the root of it is this pentagon which is extended. Now, one of the arms is further extended here. Okay, and again it gives rise to variations, and this is hexagon as against pentagon. Okay, so you can get combinations, and again when it is in 3D it can make a wonderful beautiful pieces. Okay, and you can extend one of them. Okay, so this is dynamic geometry. So, it makes it interesting. Okay, and then you can apply it in a modular form, and it starts creating different 3D objects. Okay, and you can apply it. Okay, you can go apply it on the rooftop, as a tree next to your house, or inside the living room itself. Okay, so you can have different combinations of the GeoLights. You can see here GeoLights just splattered around in the garden, okay, as part of the environment, and that is how it could actually look at night. So, that is on the land, that is on the air, and you can also put it on the water. And then of course, you have to study the basic unit of this, which is nothing but solar cells and the circuits and the light emitting diodes. They are the combinations which make this possible. So, what all combinations can you make out of it? And then final detailing of the final design, which is the basic module of the GeoLight itself, further extended, and there are many details. These are fine detailing of the basic module, okay, keeping the geometry in under consideration. So, if you look at its pentagon, but one of the components is extended. So, one extension and the other 4 are normal. Within that you can have many combinations of that. That is fine detailing of it. Then if you want to put it into a package, the packaging detail for that. Okay, so, the geometric constraints are kept together. If you want to join 2 of them together, what is the joinery details? Yeah, because you can make many combinations of them. So, finally, you come to something like this, which is the basic unit, and it can be combined in many forms, and and once you put the shade onto it, that becomes the geometry, and that is the geo family here. Okay, and you can have many combinations like this. Okay, so, there is a mother and there are child, and this is how it can be fixed together. These are the components which combine together. Okay, so, that is the detail of the mother, detail of the geo children here. So, he is actually made a family out of the GeoLights itself. Of course, you can vary the colors. So, you can have a combination of different colors which adds on to it, and you can also do permutation combinations. Okay, you can have different pattern combinations to make different layouts and combinations, right, compositions itself. Okay, so you can see that there is a formula 1, formula 2 is a different grid, formula 3 is a different grid, and formula 4 is a different grid. Okay, something very similar to how you play on Rangoli patterns. Okay, and of course you can put it as, you know, tree installations. You can extend it on a long pole, and it can give light to it. Okay, or you can put it in between building to create a wonderful space with light. Yeah, it could be part of the cafeteria to provide light. Yeah, it can be part of the street lamps, and you can see the beautiful street lamps, you know, which combine, and you can use many different materials to make these combinations. So, the joineries could be using different materials. Okay, so that is an exploration. Even, of course, this is a challenge all of us have. When you think of a new idea, think of a new name. Okay, and also how to put the new name, what is the visualization for it. So, you can look at the typography, the colors, the combinations of it, okay, and then you decide on one of them to go forward. Okay, so, this is a very brief look at ideation. You started with the modular structure, you made variations of it, you followed geometry, you put in constraints, you got the basic unit, and then you can combine that basic unit into multiple functionalities. Okay, so that's how ideation happens, and you can look at it. He's used all the techniques of ideation in creating the different ideas that have been presented here. Thanks for listening. This is section C9 of week 9, case study. Let us summarize week 9. We went through ideation, creative concepts, brainstorming, idea sketching. We looked at all the tools, brainstorming, idea sketching, scamper and lateral thinking. We applied it in the project, and we looked at a wonderful example of, you know, applying ideation in GeoLights. And the next week would be further ideation. Okay, so we will also look at a new technique called synectics, which is a very, very interesting techniques you could use further to come out with more ideas. We will also look at how you can actually map the concepts together and then evaluate concepts to pick up the most prominent ones. Okay, the tools will talk about detail of these, okay, and then you apply it in your project. Okay, and then we will have another look at another case study, which is ideation 2.